Let's check out this simple example about Coulomb law as a demo example, and to see how Coulomb law problems can be solved. This is just a small or simple problem. So here we have two charges. The distance between the two charges is known as 0.3 meters. One charge is 9 microcoulomb, and micro is equal to 10 to minus 6. You will see this a lot in these kind of problems. Micro, nano is 10 to minus 9. Pico is 10 to minus 12. So this is 10 to minus 6. Okay? So we have a charge, a positive charge, 9 microcoulomb, and another charge that is negative, minus 2 microcoulomb. We need to find the force that charge number 1 exerts on charge number 2. The charge number 1 exerts on charge number 2. Remember, this is a mutual force, but now we are actually trying to find how much of this charge is exerting on this charge. It's the same as what this force is exerting on this one, but the difference is going to be the direction. Remember, force is a vector quantity. Now if we specified how much of this charge is acting on this one, so the object of interest is this charge. Okay, so this object of interest is this charge. It's falling within the vicinity of this charge, and this charge is acting on it. Since this is negative and this is positive, the direction of this force should be like that. And let me write it in this. So the direction of this force, which is the force of 1 on 2, is this direction, because it's attractive. And look, it's on the same line that is connecting between the two charges. Okay, since we are talking about electrostatic force or Coulomb force, let's write down the equation. Coulomb's force is F is equal to 9 times 10 to the power 9 times Q1 times Q2, and this whole thing divided by the distance square. Now 9 times 10 to the power 9 comes as it is. Q1 is equal to 2 times 10 to minus 6. Now you're going to ask yourself, where is the minus? Well, the minus here is just actually to indicate here that this force is coming this way. So when you are plugging charges in Coulomb's force, you do not plug in the sign of the charge. You just plug in the magnitude. So don't worry about the sign, because you already took care of it when you indicated the direction of the force. Okay? Now times Q2, which is 9 microcoulomb, which is 9 times 10 to minus 6 coulomb, divided by the distance square, which is 0.3 square. All right? Now, before you start plugging things into your calculator, these are a lot of numbers, as you can see. I would suggest something. Look at the numbers. Maybe in these numbers you can do something. What is it? Okay, let's see. I am going to use the blue. Look, minus 6 and minus 6, 10 to minus 6 and minus 6 is 10 to minus 12. So this is 10 to minus 12. 10 to minus 12 times 10 to the 9 is actually what? 10 to minus 3. So this goes into 10 to minus 3. Now you reduced your calculation in the calculator by a lot. Okay, can we do something more? Let's see. Now 0.3 times 0.3, this whole thing is 0.3 square, which is 0.09, which can be written as 9 times 10 to minus 2. Okay, good. Now 9 with 9 cancels, right? Then we have 10 to minus 2 here. That's it. That's what's left at the denominator. Okay, 10 to minus 2 and 10 to minus 3, it comes up as all of it 10 to minus 1. All right, that we're left off with this guy, with this guy. 2 times 9 is 18, times 10 to minus 1, so the whole answer reduces to 1.8 Newton, and that's it. And you can put just a little bit here as a indication of the direction. That's it for this problem. Thank you.